So Tomislav, you've been working quite hard.
Yeah, yeah.
Why don't you give us an update?
So yeah, I was trying to find bugs in RSpace,
Okay, so
and
what was the issue that you were tracking down, just for our listeners?
so I was tracking why we have two different situations in replay when com events was not found, or a similar situation where com events are left unused.
Uh-huh. And
And
what did you find?
So I found that in event log that is supplied to replay,
Uh-huh.
the first bug was produces was not sorted,
Ah,
and so we had situation where specifically where you have two channels that are the same, so they have the same hash, and they can then differ in the data they have
uh-huh.
use. So I sorted by all fields, by the hash of the channel, by the hash of the data, and also the persistent like a flag.
Uh-huh. And does
And
that resolve the bug?
yeah, yeah. But I found that in some situation, very rarely, I see the same thing. Where not completely the same, but I see that I still have com events left. And I'm talking about super simple situation where there is only one consume and only two produces.
Okay, so
So
you have in the case of a race condition, then what happens?
yeah, yeah. So in our space we have different handling of how in which order these events arise. So we can have which is usually two produces. First come no. So first come two produces, and they are written to tuple space. And tuple space, I mean in memory tuple space, like hot store.
Yeah.
And after that, when consume happens, it will find both of these produces, and com events will happen. But uh, more rarely, it can happen that consume is not at the last place, and that was the source of the second bug, because if produce is on the last place in the code, when channels are the same in the join, uh, this code will not append existing data on this channel. And there is existing data because we have two producers on the same channel.
Got it.
So so this existing data was just left in the air. So I appended this to data that is currently on this current produce, and after that, com event happened.
Okay, so
Because I noticed, yeah.
Go ahead.
I noticed that even if in the case of when producers are not first, I noticed that there is a written produce in tuple space, which is strange because we have continuation. It should happen, but instead just produce was written again, and that was the second bug.
Wow, very good, very impressive. Most wonderful. Most wonderful.
But I also must say that this is not completely the end.
Okay.
If one of these produces is persistent, then again we have a race condition in which replay can go in different direction, and ends up in situation where you don't have com events, or you have left comments.
Wait, so just describe the situation one more time.
So for example, the same situation as I described before. Two producers and one
Okay,
consumer.
so a basic race condition.
Yeah, yeah. And one of the producers, if it is persistent, then I see in replay, replay can fail if, so if, for example, play takes one of persistent data and one of not persistent, then replay can, for example, take two persistent producers.
Oh,
And
that's correct. No, that's not a bug in our space. That's the bug in user code.
Can you explain?
Yeah. So so that fundamental non-determinism is not replayable. And well, let me think about this. So
Can I share my screen just to show example where I'm debugging this?
Yeah. So I mean, the issue is you shouldn't. If you were going to replay that, then you'd have to mark. Then you would have to mark that. Yeah. So like, when you have.
Is this maybe similar to how we mark peaks in like opposite direction? This is how this looks this to me right now.
You would have to mark a you'd have to mark the fact that one of them that you had that distribution, because because there's the persistent thing can always spin out another output. That's its job in life, is to infinitely spin out outputs.
Yeah. Okay.
Right. So so that's so if you wanted to be able to replay that, then you have to carry the information in R space that you used one from the persistent and one from the other, and you'd have to pass that along in replay to replay.
Yeah.
Okay.
So I just wanted to ask, so apparently there's nothing in the event logs currently that will make that distinction for us.
That's
right?
exactly right. You would have to address that in the event log.
Right.
You'd have to say, one of these came from a persistent gadget.
Mm-hmm, mm-hmm. I mean, there's no inherent issue with doing that, right?
No, I mean,
of course, there's probably
a user, right? Someone who's writing Rowline code and expecting there to be a deterministic outcome in that situation.
Yeah.
Right. So the other thing that you could do is to do COM event equivalences. Oh yes, right. Because yes. Okay. So here's the thing. If you do X bang some value par persistent X bang the same value, then that's the same as just persistent X bang that value. Now, if you're doing different values, then that's not the same.
Right.
So, but that should be detected, right?
I see.
You mean detected just because the value is different?
Yeah, that's right.
Okay. Yeah, I guess the one thing that I wanted to say to your point is about non-determinism is the evaluation is still non-deterministic. It's just a matter of having the replay do exactly the same thing as the play.
Yeah, exactly. But so I mean, is the comm event sensitive to the values on the output?
Yeah.
Oh, okay.
I
In that
it
case,
must be.
so hang on. What you should have is, hey, can I grab this screen back?
Oh yeah, sure.
All right. So, can you see my screen? Let me just grab a
Yes.
scratch buffer.
Yeah.
I tried it just now with different values, and I see the error.
Well, okay. So here's what I'm saying. So I'm just going to use a funny notate. I'll use star for persistence, so we don't get tangled up in bang interpretations. Because so star x v in parallel with x v is structurally equivalent to. Let me just write it this way. Structurally equivalent to star x v, like that. Does that make sense?
Yep. Yeah.
You can't distinguish those. However, suppose that v is not equal to w. Then you have that star x v star x w, that can't be squashed down into a single thing. Okay, so if you have distinct values, so in replay, right, it doesn't matter if it gets one from here and one from here or two from here, right? Because if it gets two from here, you can always still absorb, this one back into this one.
Yep.
If you get the error in this case, where you get in the play you get one from here and one from here, but in the replay you get two from here, that's a bug.
Yeah. Okay,
does that make sense?
Yes. So in the first case, we need to apply this rule, right? Because
yeah, you need to apply the rule. You need to say the comm events are actually the same.
Yeah, and now we are distinguished between this situation because we are just comparing the structure, and in one structure we will have persistent true and in another persistent false. So can this be done on the level of on some other level in the play, where we can say, oh, I have these two producers and I will always use persistent.
Yeah, I mean, it's almost like a macro, right? I mean, you just, like as you're parsing the term and you notice you have persistent and non-persistent on the same channel with the same data, you can just rewrite it.
Yeah, exactly. I mean, what I would do is I would run this rule in this direction, right? So it would be forced to always take it from the persistent.
From left to right, you mean?
Yeah, from left to right.
Yeah, definitely.
So when you're either when you're parsing it or normalizing it or whatever, right? You just force all expressions of this form into this form. Now it gets a little tricky, like, so that the tricky situation is this one. Here, I'll do it below these two.
Oh, I just wanted to say that I don't know how I didn't realize it until you wrote that first equation.
Yeah.
How similar the persistent send and the replicate operator are. I guess any kind of persistent thing, right? Because
they're all replications.
Right. Yeah.
So, but if you have this, right? So the question is whether or not the normalized process will rewrite this to this.
Yeah. I mean, this must
If
be
it,
before.
if it always puts the X next to the X star or the star X, right, then you're golden. But if it doesn't, then detecting that you've got this situation is trickier.
Yeah, yeah. I'm wondering if this is possible, because
Maybe it shouldn't be done at parse time, but you do it, you know.
Yeah, after the terms are sorted and
Yeah,
scored.
after everything's happened. Yeah.
but it must be before this is written to tuple space, because if this unpersistent produce is written first, then we cannot go back, right? We will already have this this non-persistent produce in tuple space, so it must be before that.
Yeah, well, I mean, you can also
Yeah.
solve it on the back end. You can, like, if you see that one of them is marked persistent, like you catch the error, right? So if you have these unused COM events, if you marked the information on the COM event, right, then you could detect, oh, actually, I can ignore this one.
Oh, I think this will be. This is not easy to implement, I think.
Okay, I'm just saying,
Yeah.
you can do it on the front end or the
Okay.
back end, whichever
Okay.
one is easiest. Yeah.
Okay.
Cool. Well, on my side, I haven't done a lot of Casper research, but I did this yesterday rewrite the tank calculation code. I was trying to be like functional before, like not use any side effecting, but it turns out that the transaction graph has cycles in it, and which is odd. I was expecting it to be a DAG, but it actually has cycles in it. And so when you have, you know, cyclic graphs, being purely functional is really tricky. So I rewrote it to use some side affecting cycle detection. So I'm just in the midst of finishing that up, and should have a better tank calculation. But it was really funny. I didn't until I started looking at the data a little bit more closely, and noticing, oh my God, there are cycles in this transaction graph. How can that be?
Yeah. And from where are these cycles?
Well, they're really simple ones, where very short one-hop cycles, right, where the transaction goes from the source to itself. And you'd think that those kinds of transactions would be prevented, right? That those would be optimized away rather than, you know, mined.
Oh. Yeah.
But there are other ones which I'm really mystified about. So anyway, but I've got a different cycle detection algorithm, the side affecting cycle detection thing that. You know, it's a much more naive calculation. Before, I was doing all this, you know, really fun stuff. I mean, whenever I write anything, I try to make it fun for me. So I was doing all kinds of really nice stuff here. I'll show you what I'm talking about. So I have, you know, two tricks. One is this justification trick, so that and I've written it completely generically, right? So it doesn't know that it's dealing with transactions or anything, right? It just knows that it's got anything that is justified has a set of justifications of the same type, right? So and that way you can always calculate paths from a particular justified gadget, right? So if you make your transactions justified, then you can calculate paths back to the source, right? And that's a completely generic calculation, right? It doesn't know anything about transactions or edges and graphs or anything. It just knows that it's got a pointer to its set of justifications, right? So that's all the parents coming into this thing that, you know, provide the justification. And likewise, you know, I've got a completely generic notion of closure, right? Just it keeps a key and a source, and what it keeps an accumulator that is a map from key to sets of sources, and then you know and then you have to have some function that says, if I have a source, give me the next chunk of sources, so the next generation, the children of that thing. And then I also need to be able to get from a source to a key. So so then it's literally just a fold, right? You fold over the
all the edges are.
You fold over the next generation of, like, from source, right? You have all the things that this source will give rise to. So if I have a transaction, it's all the you know outgoing transactions from the target of the transaction. That would be your next set of transactions, right? The transaction is coming from a source into a target, and what's the next generation of transactions? Well, it's all the transactions coming out of the target. So all the transactions that have the target as a source.
Yeah.
So that's the and so this is completely generic. It doesn't know anything about transactions or anything like that. And in fact, if you look at the way I tested it, right? So I have a simple way of describing a graph, where I think of a graph as a set of edges, and then here's a simple example graph, and then this describes how to go and get the transitive closure from a particular edge.
Nice.
Right. So this is completely generic. Doesn't know anything about that. And then my first approach was to actually this is the second approach, but it's just to you know I make a notion of an edge that matches a transaction, and then I have the identity edge, which I use for the you know the origin of the taint, and then you know I just you know essentially I walk the transitive closure. So this walks the transitive closure for the to go and calculate the weights of the taints and that sort of thing. But after doing this, then I realized, oh wow, there's cycles in this graph. I have to be careful. But the one thing that was naive about this, which is also busted in the spec for the taint, is you have to account for. Let's see if I can draw this. Like, do I have a drawing program? Let's see. Get a new browser. Online drawing.
Draw.io is one.
Draw.io.
Yeah.
Come on, fingers. Whatever device. Does this allow sketching? Like
yeah, I mean, yeah, it's for diagrams, and it has lots of, yeah.
No, but does it allow me to do free sketching? No. Let's see, online.
I'm not completely sure.
Sketchpad, online sketchpad. All right, yeah, this so I can undo. Where's the undo? Okay, all right. So suppose I have you know, this is an address, and I have a transaction coming in here, and I have actually a bunch of different transactions. So dot, dot, dot. And then here's another transaction coming in. Okay. This is a terrible, I don't want calligraphy. Is there some other pencil? And then I wonder if there's some. Okay, let's see, maybe this one. Okay, so here's my address. I've got a transaction coming in like this, dot, 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 and another, you know, so these are all the transactions that are depositing into this. Now, and then likewise, I have a bunch of outgoing transactions. Okay, so this is the situation. Now, when I want to, so let's say so we have some pure is translated along here, plus some taint is translated along here. Okay. Then to calculate the taint that this contributes to outgoing, we want to look at all of the outflowing that are after this one, but before the very next one by timestamp. Right? So it's this subgroup here. Let me change the color. Huh. I have no idea. That's weird. I have no idea how to use this. But anyway, so you want to calculate these, but you know, the next group, so these will all use up all of this, but none of this. Right? So anything coming out, like, you know, a transaction here, which is coming out, oh, that's weird. So anything coming out after that group, right? So, you know, this one, let me just add one more just for fun. Let's say that these two here come after this one, and then this one comes after that one. So then, you know, if this is P prime plus T prime, just to be super clear about it.
Oh, so we need to eliminate some output that is happened after.
Yeah, exactly.
Before.
And that's wrong in the spec. I didn't account for that in the spec. So that's so I just was fixing that up. Oops. So P plus T is, so if you want to look, so this will take up P plus T minus these amounts, right? So, you know, if we have, you know, A1 through AK, then you'll take P plus T and you'll distribute it by the weights of each of these, right? So if I have, you know, an amount A through AK, A1 through AK. Sorry for the messy drawing here. Okay, so what you do is you go and you sum AI, and then you divide that. So the weight of the the weight of the jth transaction, so we're not confused. So the weight of AJ is going to be AJ over the sum. Does that make sense?
Yeah.
Yeah, but you can only consider these, not all of them. And in the spec, in the board policy spec, I was taking all of them, right? So that's your, and then you multiply that by, you multiply the weight by P to get the pure amount that goes along here. And you multiply this by T to get the taint that goes along here. Or, you know, P plus T times this weight should equal A, right? So if I took weight of AJ and I multiply it by P plus T, right? That really should be, that should be equal to the AJ. Does that make sense?
We might have some rounding errors though, right?
Yeah, there'll be some rounding errors, but
They should be pretty negligible though.
yeah, they'll be negligible. But do you see this equation, right? This has to be true.
Mm-hmm. Mm-hmm.
Yeah. So then yeah, and so so you have to group them this way, right? So like that, and then like that. So you have to you look at all of these, and what I was and in doing that sort of thing, and so that's what goes on in this, in the naive version. So if I'm calculating the taint of a particular transaction, right? So I want to calculate its weight and multiply it by its the taint of. So if I'm calculating the taint of this transaction, I want to go and get the deposit bounds of that transaction, then there's some cycle detection code which makes this look more complicated than it is, right? So I also memoize everything so that once I've seen the taint of a particular transaction, I never calculate it again. So I'm for all the walking, I'm keeping a state, and this is the side effecting part. I keep this state, right? And so inside the state, I've got some memo maps, right? So I grab this and I grab the possibility, you know, the cycle detection. And if I've never seen it before, well, then I just go and run the base case on, you know, so all of these cycle protected things have this same shape. I've got to check for cycles. If I don't have a cycle, run the base case, otherwise deal with the cycle. So that they all look like this, you know, sort of by convention. And then, but in the base case, I go and get the deposit bounds, right? So that's going to be essentially the it can be it's a pair of options. So it could be that we don't reach this from any tainted gadget, in which case this is a pure source. So so it's not possible that it's tainted. But if you can reach it from some tainted source, then you'll get a lower bound, right? And you're interested in so what I mean by upper and lower bound. So for this group, this is the lower bound, that's the upper bound. And it's just, the way to detect that is the timestamps of all of these must be greater than the timestamp of this and less than the timestamp of that.
Oh, I wanted to ask a question about this diagram real quick.
Yeah, sure.
So that first incoming arrow, the P plus T, that's like all of the transactions up to that point.
I'm looking. I have all of the transactions, right? So
yeah.
So what I've got are all the transactions from a particular block height to another block height, right? So it's basically from when tainting started to the max block height for our chain. Or yeah.
So I guess the reason that I'm asking is I kind of took that last equation as like, oh, this is really obvious, and then I started thinking about it, and I was like, wait a second, that equation isn't true unless P plus T is the entire balance of the account at that point in time.
No, that's not. Yeah. You have to look at the balance beforehand. Yeah.
Okay, you can just adjust for any balance prior to this tainted incoming transaction.
Yeah, exactly. But I mean, the point is you this is the first time you've ever seen any taint. And we're only interested in taint. So pure goes to pure. But this is the first time we've seen taint. So what we're saying, so even if there is a balance here, whatever is here prior to this point is untainted. So you know that this how do I say it? You know that regardless of whether or not there's a balance, that W AJ.
But we are not counting existing balance and whatever was left before, right?
Right. So if I just do that times T, this has to be equal to the taint of, oops. Sorry, not used to drawing this way. The taint of AJ. You can take this as a definition.
Yeah, definitely.
Right, and that's independent of what the balance is here.
I 100% agree with that. Yeah.
Okay. Good.
I have a question about this. The transitive closure is like path, which path to the edges of the transaction, right? Source and
Yeah.
And in this case, we have additional constraint, right?
Yeah.
Exactly what you said with this equation.
Yeah, exactly. That's correct.
Okay.
That's right. So you have to be a little bit more subtle than what I wrote in this spec or what the board adopted. So that was why the balances were off in that previous calculation. So that's the and you know I rewrote it to include that information. I just made it just like dirt simple rather than trying to be clever. I just made it super simple. So I've just been running it. There is one more cycle case I have to eliminate, and then I'll be done. So it's an interesting little puzzle, you know.
Yeah, this is way more complicated than I was expecting it to be. Especially, you know, when you had kind of first presented it to us on the RCAS, I was like, oh, this is simple. There's like not even any questions to ask here, really. And then it's like, wow, why is there so much debate about like, oh, I didn't get any tainted coins from, you know, whatever, and it's like, oh, but there's mixing and the exchanges, and it's just like, oh wow, this is like way more complicated than it was than I thought it was on first glance. But
yeah, exactly. Well, yeah, I mean, I should have like insisted on a more formal review than just like talking about it over RCAS, right? I should have, you know, because like I mean, nobody brought up this issue. Right.
Yeah.
So maybe that's happening in Jim's calculation, but to the best of my knowledge, like nobody has pointed out this particular issue in the discussions, right? And
Yeah.
this is plainly and clearly wrong in this spec.
Oh yeah, right.
So how is this? I mean, if we look at result one that we calculated, okay, if an account has 10% scam coins in it, and they send 100 coins, then 10 of them are scam. And
No,
then
no.
they're good.
No, that's not true. Because what if before they send their 10 coins, another deposit comes in?
What do you mean? Now there's 200 coins.
So here's the situation that I'm describing. So we get these, right?
You know,
And
let me just go with that.
Hang on, let me finish. You have to let me finish. You have to let me finish. Okay. So you've asked a question, and I'm going to answer it, and then you can. So let me finish. Okay. So now we have another deposit come in, and it also has some taint in it.
Fine.
And now let's consider this transaction here out. Okay. If the timestamp of this one is after this one, then you have to consider both taint. If the timestamp is before this one but after this one, you only consider that taint.
Right, and that's exactly what we're doing. At the time of the transaction, let's say he has 1,000 coins, 10% are bad.
So anyway, so that's.
So if it comes out, so at the time of the outgoing transaction, the only thing that's counted is the current balance. The next transaction is not counted.
Yeah, but you can't. So if you have an API that will get you the balance at a particular block height, let me know. But without,
well, yeah, we go through and calculate it by applying the transactions in order, so that when each transaction is done, we have the current balance in the account at the time of the transaction.
That's great. So that's what you need to do. You either need to pre-calculate it, or you can, I looked for an API. I looked for an API that would allow you to get a balance at a particular block height, and there isn't one that's on the web that I know about. Maybe there's one that is harder to find, but if you just go,
if you process each transaction.
Yeah. So that, yeah, but that's, yeah. But it turns out you don't have to do that. That's the other point. You don't have to process each transaction. You just have to calculate the lower bounds.
It seems a lot simpler.
No. It's much simpler to not go and calculate all the transactions, because you have to build up the entire history. Here, look, this is what I'm saying. To get the taint for this transaction here, you calculate the lower bound, which is which one of these, right? That's all you need to do. You calculate the lower bound. So in particular, here's the line of code. So I go and check my deposit bounds. If there's no lower bound, that means this transaction is pure. If you do have a lower bound, then you know that it's the weight of that particular transaction, right? So that's this thing here, the weight. And it is times the taint of that lower bound. If you have no lower bound, right? So if there's a cycle case. In the case of a cycle, then you have to be careful not to go calculating taint again, because you'll come back to yourself. That's how complicated it is. And what this does is it means I don't have to go and calculate all the transactions. That's the other point. And I don't have to go verify whether or not I've calculated transaction balances correctly. That's the point of this argument. I don't have to go through the history. I just have to look at where these transactions fall with respect to these inputs. That's the point. Does that make sense?
It still seems a lot more complicated than just having one loop that goes through and applies each transaction and moves the proportion of scam tokens and live tokens. Very clear, very simple. And I think it should get the same result, right?
I think that's a great idea to just implement both approaches, and then you can just compare.
Yeah, exactly. And just compare them.
Yeah.
Yeah, that's exactly right. Yeah. Very good.
Okay. And then, based on feedback from the community, we have results 2, where we treat rock coming from ether delta as good. And then approach 3, which is results 3, which they seem to like best, which is it always moves the good rock in the account. It leaves all the scam rock there until it has no good rock left, and then it moves the scam rock. And we had like 700 people affected in case 1, and we have 60 people affected in case 3.
So let's think about that. No, that's not fair. That's why you have fewer people affected, because you're being unfair. What you're saying is that across all these deposits, you're going to collect all of these to this transaction. So this person over here is burdened with the taint, whereas all of these get off scot-free.
Well, it doesn't exactly happen that way, but I understand it's unfair. But it's not clear that any approach is fair.
No, that's not true. That's certainly not true. This is the most fair approach, right? What we're saying is all of these addresses share this burden, right? And then all of these share this burden, right? So, you're distributing the taint as equally as you possibly can. As opposed to what you just talked in approach 3, what you said is, now there's nothing here, right? There's nothing here. As long as these amounts don't sum to the taint, right? So as long as these come under the assumption that these all come under the taint, then the taint would all go to this address, and that's totally obviously not fair.
Well, it's a matter of perspective. I mean, if you receive 10 scam tokens, should you be allowed to spend those? Should you be allowed to send them to a third party?
You don't know.
That's an issue. I mean,
but the point is, when
you have stolen property,
but when
you're not allowed to sell it.
Yeah, when they hit an exchange, you didn't know that you received the tainted tokens. You were completely out of the loop on that.
Right.
So you didn't know that you were spending it. So the best thing to do is to share the load. Right?
Yeah.
Okay, so that's all I'm saying. So approach 3, I'm sure people like it because it means that 60 people share the are the ones that shoulder the burden, as opposed to 700 people shouldering the burden.
Sounds like a debate for democracy.
Yeah.
No, I think
that's exactly right.
I think if, the tyranny of the majority in this case would be for case 3, which may not be, which Greg's suggesting is not the best one.
I'm not sure that that's the majority. I think it's a vocal few. Like actually collecting the opinion of the majority would require first educating them educating everyone on exactly the discussion that we just had, and then collecting a vote which we felt was fair, a fair and reasonable vote, right? But if you just have, like, you know, 3 people going, yeah, that's the way, you know, then that's not a majority.
Yeah, well, we do have, we have at least a half a dozen on Telegram, and that many on Discord, and the people that are watching have.
Yeah, so I mean that's like 12. That's 12 people out of that's 12 people out of 1,000 KYC members, right? That's not a majority. It's not even 10%.
It's pretty much unanimous among the people who are knowledgeable and care.
Well, if they're knowledgeable and care, and they want one person to bear the burden where none of these do, that doesn't seem particularly
Yeah.
I would be really, really astonished. I don't know that this description has been laid out in quite this way.
Yeah, and I don't know why people are so upset if they have, less than 10% scam tokens. But
well, I mean, especially when you consider that the price swing on the token is far greater than anything that they're hit with in terms of scam. So that to me is like, I think it's entirely psychological. So anyway, I've got Dev stand up in just a few minutes. We'll take some time to finish up this cycle case, and then we'll be done. Thanks, guys. As usual, fun discussions.
Yeah, thanks.
All right.
Bye.
Ciao.